When it comes to product manufacturing and quality control, obviously the most effective way to ensure that you're not selling defective products would be to conduct a 100% inspection on all units. However, this is extremely inefficient and often costs a lot of money. Acceptance sampling is a process which is a part of the quality control process that is used to determine the overall quality of a collection of products without having to inspect every single unit. When a producer sends an order of products to a consumer, referred to as a lot, the consumer may select a sample from the lot and execute certain methods to test the quality of the sample. The results will indicate which units within the tested sample are defective and which are not. The results of the tests will then be used to represent the expected number of defective units among the entire lot. If this number is more than desired, the consumer will reject the lot, and if not, they will accept it. Consumers will typically decide on an acceptable percentage of defective units for which they are willing to accept the lot, and if the lot is rejected, the consumers will then decide either to completely discard the defective lot or to conduct further inspection to remove all of the defective units and prepare to ship the lot once that has been done. Consumers will typically decide on what they feel to be an acceptable percentage of defective units for which they're still willing to accept a lot, and in standard practice this number is usually 2% or less of the units being defective, but because of the different nature of different products, this number can vary at the discretion of the consumer. The operating characteristic curve displays the probability of acceptance versus the percentage of defective items. By examining the OC curve for a given sample size and target defective percentage, we can determine the likelihood of accepting a defective lot. This allows us to decide if we're comfortable with those probabilities, and depending on the results, we may feel that we need to alter the size of the sample being tested. The graph shows multiple OC curves with varying sample sizes of N and acceptable amounts of defective units indicated by C. For all of the curves, as the percentage of the lot which is defective increases, the likelihood of accepting the lot decreases. Also, as the sample size increases, the likelihood of accepting defective lots decreases. Engineers inspect graphics like this one to find a sample size that is large enough so that it can accurately represent the entire lot while not being excessively large, which would lead to wasting money on testing. Quality control is an important part of any production process, and acceptance sampling is extremely valuable for quality engineers and industrial engineers working in many different industries. Suppose you're a quality engineer working for a company that sells light bulbs. You may communicate with the manufacturer and conclude that you will sample 50 light bulbs out of a lot of 1,000, and if 2 or less are defective, then you will accept the lot. Light bulbs are something that are easy to return and replace if a customer receives a defective one, so you may decide that you would rather not scrap an entire load for that small of a number of defective units, which could cause you to decide on a new acceptance number of 5 out of 50. The main drawback with acceptance sampling is that because it's only a sample of the entire lot, you cannot guarantee that it will be an accurate representation of the entire lot. But acceptance sampling is effective because it saves the cost of testing an entire lot of products, and it is a process which can be adapted to all sorts of products depending on the preference of the engineers involved with the process.